I'm just kidding. I'm actually not in space. I am here in Long Beach, California, with the Aquarium of the Pacific. Can you tell it's our 2 p.m. show? So hello, everyone. So glad for you to be able to join us today. My name is Jen, and today, as you may have guessed, we are going to be discovering Earth. Joining me in the studio is Kaya. She's going to be helping me with some of the images, though many of the images that we will be seeing today are actually through our Science on a Sphere program, and that's a program by NOAA, so the National Oceanic Atmospheric Administration. Try to say that 3 times fast. But if you do have any questions, please feel free to go on ahead and email us down or text us down below, 562-286-1838. All right, so very excited to be talking a little bit about Earth today. So excited that I was inspired to create my little space helmet here. All right, maybe if you want to make one, you can join us in a future Crafty Critters program. But in the meantime, friends, we're going to be talking a lot about Earth, one of my personal favorite planets, though I may be biased. Is it your favorite planet? It's okay if it's not. Kaya's, definitely. James, yours? Yep, his as well. So, let's go on ahead and talk a little bit about the awesomeness that is Earth. First of all, let's go on ahead and take a look at our Earth. Ah, ain't it grand and beautiful? Now, as I go on ahead and put my space helmet down, I'm going to be controlling this through an iPad. So, you'll see me here, and I have an iPad that is currently connected right here. And so what I'm going to be controlling on my iPad is going to be what we're all going to be seeing in our images back behind here, except for when Kaya takes over and shows us some really cute animal pictures. Because Earth, of course, is full of wonderful critters that we will, of course, get a chance to talk about. So with that, I'm going to move aside, and I can spin my Earth around. So you can see how I'm spinning the Earth around right now. And first of all, a lot of what we're going to be seeing are through satellites, right? That's how we're getting our pictures that we're seeing right here, are through all of these satellites. Oh my, it's getting quite dark, isn't it? Huh. So, is this a pretty accurate way to be looking at our Earth? Still pretty dark. Is all of our Earth dark? What do we notice? If you're saying, yeah, of course it's normal for half of our world to be dark, you're absolutely right? So the sun, as our Earth is moving around and orbiting around, we're able to experience a lot of sun on one side of our Earth, and then darkness or nighttime on the other side, right? So as we're going to focus on the light side, the one that the sun is hitting right now, because, well, the other side, it's just pretty dark, right? But if we look on this side right here, what are some colors that, oopsies, sorry about that, folks. I'm spinning the world around. Hope you're not too dizzy. As we look at our Earth here, what kind of colors do you see? Kaya says she sees blue. What other colors do you see? Green. Absolutely. My favorite color. Though blue is my second favorite color. Just depends on the day. What else do we see? Trying to reorient us with our Earth right now. There we go. Ooh, did you say... I was about to say yellow. Did you see white? Yeah, white. So Kaya's mentioning that white might be clouds. Do you agree? Kaya definitely agrees. Now, if you also go on ahead and look, here I'm stretching our Earth over to one of our poles that we see right here. Now, are those clouds? Maybe not. Let's check out our other pole. So we're going to zoom through Earth. Watch us go. I, too, like to make sound effects, much like James when he's drawing, except when I'm rotating through the Earth. All right. Now, the rest of it, I think, might be dark, so it may be kind of tricky to see, right down here, right? But what do you think? Do you think all of that whiteness, if it was daytime, do you think that would be clouds as well? No, right? We're thinking probably ice. And for sure, right? So all these colors can mean different things. We're saying that the white might mean clouds, or it might also mean ice, right? What about the green parts that we're seeing here? Right here we're focusing on North America right now. What do you think all that green might be? Things growing, yeah. So maybe some shrubs, maybe some trees, maybe grasslands, prairies, meadows, all that kind of stuff. Now, do you see any other colors on land? Ah, Kaya says she sees deserts. What kind of colors might give away that we're seeing some sand or earth that's really the dominating feature? The orange color, absolutely, right? So we're seeing all these different colors, and all of these colors represents a different part of our world, right? Like the blue, probably the ocean, right? Or water features like our Great Lakes right here that are freshwater. So there's lots of really cool things that we can look at just by looking at our Earth, right? Ah, it's good to be an Earthling. All right. But now we as scientists can actually get a chance to look at Earth in a lot of different ways. This is just the way that we happen to be most familiar with it. But believe it or not, there's lots of cool ways that we can change our science glasses to be able to see something even cooler. At least I think it's pretty cool. Once again, maybe biased. But let's go on ahead and check out another feature. I'm going to step to the side, and we're going to be looking at a way that we're actually able to get some of this information. Because we mentioned earlier that a lot of this information that we are getting is all through satellites, right? Now you may have just had a chance to see a little sneak peek into what exactly we're looking at, but we have lots of festive little dots. Now it's not confetti, but that would be fun. We're celebrating the Earth, right? All confetti all around. But what do these pieces represent? Any clues? Yep, buoys right here. Now, if you're not familiar with buoys, maybe the location of these buoys may give you an idea of if it's a scientific instrument, right? So it's something that we use to measure. Where do you think we might be measuring? Do you think we're measuring things on land? Or do you think we're measuring in the water? We're thinking maybe fresh and salt water. Let's take a stroll through the Earth, shall we? Look at us go. How relaxing. All right. Noticing anything yet? Yeah. Saw a bright blue color. Boop, right there. No confetti pieces in there, though. Sure is beautiful, though. All right. Gotta love the colors of the Earth. Yeah. So I don't know about you, but I am seeing tons and tons of confetti pieces, right? Of all of these little markings right here in the ocean, right? Kaya also went ahead and mentioned that she sees some of these buoys in freshwater places too. Now, Kaya and I sit next to each other in the office, so she's often my thought partner and tells me lots of great things. So it's nice to have her back behind the computer helping us out today. So with all of these, right, can you figure out, is there a green on our little key right here? Yeah, absolutely, right? So this is one type of buoy. These are different types of flotation devices, basically, and they float on the very top of the water. Now, you can attach a lot of different things to these buoys because they always kind of stay in the same spot. They are generally attached with a large chain and an anchor at the very bottom, and they're able to rise and not sink, but like rise and stay at sea level. So if there's a wave, guess what? This buoy just doesn't get smashed with the water. It will grow with the energy and come back down. So it's always sitting at the very top of the ocean. Now, with that though, that can tell us a lot of information just in general, right? How tall, how much it has to rise and fall can tell us how tall waves are in that particular area. We can learn the temperature of the water if we put out temperature sensors, right? We can learn, gee, what else? If you have any thoughts that you'd love to share with us about what kinds of things scientists might put on these buoys to study, feel free to go on ahead and text on in, right? We'd love to hear your thoughts because, scientists have definitely thought of different ways or different things that they could add on to buoys to be able to learn about the ocean. But maybe you might have some fun things too that we can explore together as we look at some of these data sets. Yep, that's what we call them. All the different types of images that we're seeing with all the different color, all of this tells us information, right? And this information, well, in science we call it data, right? We're always collecting information. We're always looking at information. We're always trying to understand what this information means. And so this is a great way of getting a chance to look at it. Now, for me, right, as we were talking earlier, we know just from looking at all of these little confetti pieces, right, that all of these are buoys, and we know where all of these different buoys are located. And we have lots of different types of buoys too. Now, some of these buoys mainly, might focus on getting certain types of information, and we can get that all throughout satellite networks that may transmit that particular data from that buoy all the way up to the satellite, and then it goes to a computer where the scientists are able to access that information. So it's pretty neat stuff. All right, so let's go on ahead and let's look at a data set. And what I love about these data sets is that many of them are colorful. Oh, looks like we have a question of how do we get the buoys in the ocean? And that is a really good question, as I've never seen, so I'm driving on the freeway, there's like a truck with a buoy on it, but maybe, right? I don't know the exact ways in which buoys are able to get, how they are built and then transferred to the ocean, but I would imagine these buoys are heavy. They are, I don't know, definitely big enough for several sea lions to hang out on. So they're definitely larger than 6 feet. I would say probably maybe about like 15 foot in diameter, maybe thereabouts. So they are quite large. Where you can imagine. Thank you, James. So 3 meter, 10 meter, and 12 meter? 12 meters in size. So that's up to 36 feet, which is pretty large, right? And the 15-foot one that I was mentioning is just the smallest. So sometimes you'll find seals or sea lions that kind of use it as a place to haul out or to warm themselves or to just kind of rest and relax. But all of these buoys are probably built in some sort of facility and then put either on a semi-truck or like a flatbed semi, anything to kind of tie it down because they are made up of metal, and then, brought over to where they need to be. Now, once they are out in the ocean, not exactly sure how they are able to drag it out. Because I would imagine that maybe the anchor isn't necessarily attached, so they might tow it out to a particular location, figuring out the coordinates to know the exact spot, and then they can probably anchor down that buoy that way by attaching a huge chain and an anchor to sink it down so that way it stays, right? So that might be one of the ways in which some of these buoys are able to get out to some remote and odd places like we have right here. Now, one would hope, I see a lot of the Argo buoys, that maybe they built a lot of those Argo buoys and then, maybe like made a little ship bus that brought them all out, and then they can put them all in their places. But anyways, thank you for asking. So hopefully that kind of helps give you an idea of a possible way in which these buoys can get out to our oceans. All right, so I'm going to head back to our data sets here, and we're going to get a chance to look at another neat one. This one focuses a little bit more on, well, maybe you can try to figure it out. And if you're watching on the side, it may give you a clue. All right, I'm going to switch to water because somehow we went to all locations. But what's really cool is that you can check out all sorts of things. We're just looking at ocean right now, but there are so many different options that you can choose from land to ocean to air and anything in between. So it's pretty cool. All right, so we're going to start with this one right here. It's going to take us a few seconds to load on up. Now, we had a chance to look at colors, right? All those different colors represented something, a piece of information, right? So now we're looking at a different data set altogether. Once again, you may see a clue that may give it away. There are a few areas where you may see clues. Any thoughts? Yep. Sea surface temperature, right? Is definitely one spot. So a lot of times as scientists are creating these data sets, they also have some sort of key, right? Just like how we saw with the buoys, all the different colors meant different types of buoys. In this case, we're looking at temperature. So what do you notice on our key that we have right here? What do the colors represent? Ah, it's kind of warm. I'm just kidding. It's just a picture. But if we go on ahead and we look at our temperatures right here, right, we can see that red means that it's hot, right, or pretty warm water. Any guesses to how warm that water might be? Maybe about 86 degrees, right? If you're in the United States, that is using Fahrenheit, right? If you're a Celsius person, maybe about 30 degrees or so. Still quite warm, right? And then as the temperatures get cooler, right? As we go from red to kind of yellow to green to blue, and almost like a dark blue, so the cooler colors, right? We're getting into colder water temperatures right here. So I'm going to step off the screen for a second, but what do you notice? Where are we finding what are you noticing about the colors in general? I'm going to move our Earth around, because right now we're kind of just in the middle of the ocean, which is neat, but sometimes that's helpful, at least for me, if I have a reference point. So I'm going to tilt our Earth just a little bit. We'll focus on North and South America right now. Let's move it up a little bit more. What do you see? I'm going to move it a little bit more across the way. Move it back on over. Whoop! My world spins quickly here. Do you notice all these colors? Yeah. Where's the red colors? Mainly kind of in the middle here, right? Any thoughts to why we have so much red in the middle? Kaya's saying the sun. Absolutely, right? So as we are looking at our planet as a whole, and of course our planet is a little bit tilted, we're seeing the sun, and the sun shines the brightest right on that equator line right there. So we have the most amount of sun hitting the water, and it's warming it up the most, right? And then from there, what do you notice? Well, I notice that there's definitely some yellows and greens. And as we definitely get higher up, right, like in California right here, it's a little bit in that lighter blue area. And if I go on ahead, and I'm going to step out real quick so I can show you some of these other parts right here. Here we have the Arctic, right? So we have Alaska right here, and we have the Arctic right here. Is that crazy? So there's some of that ice that we saw earlier. We're seeing how cold it is. Sorry, it's about coldness, right? We're not looking at ice right now. And we can see that white goes all the way down to 0. So that's super cold up there, right? And then we're seeing that temperature slowly get warmer as we go to the equator. Wow. Now, how do these temperatures, how do they change, right? Because think about the ocean. Is it completely flat and calm? Not so much. One of my favorite times of being out in the ocean is when it's super stormy out. It's a really good time out in the water. But a lot of these storms, and a lot of that energy is brought about through currents. So let's go on ahead and look at some currents to get a better idea of how currents and temperature go hand in hand together. All right, so back to my little data set here. I am going to change it up to sea surface currents. All right, let's see. Here we go. All right, so here, this time around, we have all of our land that's blacked out, right? Because we're not even looking at the land. We are focusing on the currents. So if I go on ahead and I grab us right here, and I kind of bring us back to that equator part, right? We can once again see all of that bright red right where that equator line is. Here is the Gulf Stream, right? So it's bringing hot water, warmer water up on the East Coast. But here, we can also see that green and that red and how it gets cooler too. So I'm going to step out of the screen real quick and move it a little bit more south because we looked at the north last time. I'm going to tilt it so we can focus in on South America. Even though it's a little dark, hopefully you can get a chance to see how off the coastline here, right? Go red, kind of yellow, green, and then just like in the northern hemisphere, right? We're getting cooler and cooler as we head toward Antarctica. Now we can see all of these different currents. Some of them aren't connected, right? But some of them have strong connections where they move all together and we have a really strong flow. Just like that Gulf current that we saw earlier, right? Really strong currents that drive a lot of these ocean patterns, so that way we could have lots of different animals that live there. Ooh, looks like we have some questions of, does global warming mean there's only more red on the map? Now, that's a really interesting question, right? We do have different data sets that can point to how temperatures may change over time. Unfortunately, I don't think I have one to show you at the moment, but that is one of the data sets that I think you may be able to look online and see. So you too can look at Science on a Sphere. Just on the website itself, if you Google Science on a Sphere and NOAA together, then you might be able to check out what some of those data sets look like. But what they do is they take computer models. So they take all the information that they know now about what's happening right now. And then they also take into consideration everything, all the patterns that they're noticing, right? What are some human patterns that we see, right? How much carbon dioxide are we putting out into the atmosphere? How does that carbon dioxide affect different habitats and different spaces in the ocean and land? And so they take all that information, they type it into a computer, and then computers show models over time of what would happen now and then what would happen like up to like 100 years in the future. And so from those models, you can get a general idea. Now, models aren't like, they don't know it all, right? But they can at least give you general thoughts and trends to what that might happen. So hopefully that answers your question there. And then why do some lines go in opposite directions? That's a great question. I'm going to bring it closer down to the equator so we can talk about how some of those lines change a little bit. All right, so I'm swirling my Earth a little bit differently here. All right, so if you go on ahead and you see, here we have our equator line, right? And then from there, which way do you know some of these swirls going? Yeah. Looks like we have one set of swirls. Oops, this is really testing my left and my right skills here. There we go. I have one set in the southern hemisphere going this way. And it looks like in the northern hemisphere, it's kind of going the opposite direction, right? So we can see that's going, oh dear, here we go. Nope, the other way, this way, right? And so it's kind of tricky to see. And in the middle, we have some that are swirling around, and those are the different currents. So some of these currents are moving around due to the wind. So our wind in the northern hemisphere, let's see if I can do this right, goes, the other way. There we go. It goes up and it makes this kind of motion. Down south, it's actually the opposite direction. So as the wind patterns move and they swirl, the wind helps move the water, and those water, the currents in that area are then affected by what we're seeing over here. So if you're interested in learning a little bit more about this, you can look into the Coriolis effect. Corriolis, I think is how it's spelled. And the Coriolis effect is basically talking about how the Earth spins around. And as the Earth spins, the wind and the clouds and the weather moves in a certain direction. And that the wind pattern is then moving the water, and all these different factors together basically help shape the currents of our water. So that's part of the reason why we get a lot of really great nutrients on our west coast here, is the way that the winds and the ocean work hand in hand to be able to create these different currents. It's a little bit more complicated, but that's the basics of it. So if you do have any more questions though about how wind and water currents move together, feel free to go on ahead and email us at live@lbaop, and we'll bring that up later. But that's our email, and you can go on ahead and email us with any of those extra questions that you may have, since we just kind of briefly touched upon it. I think if we had more than 4 minutes, then we talk a little bit deeper on it. But something that I'd like for us to kind of get a chance to look at are how these currents affect animals, right? Because we have so many different animals on our planet. Now, let's see if you can maybe think about some of the ways in which temperatures of our water and the way the water moves help us determine what animals live where. It's kind of a big question. But if we think about temperatures on land, right, we're not always going to find, a rhinoceros all the way up in Antarctica, right? It doesn't really work hand in hand with each other. Well, same thing in the ocean too, is that, there are certain spots that animals like to live and are better suited for in other places due to a lot of these wind currents and all these temperatures. All right, sounds good. Oh, and just as a reminder too, as we're kind of exploring, if you're like, oh, I'm really interested in learning a little bit more about the ocean, remember that it's also available online. So once again, it's called SOS Explorer, and you can download it on your computers at home, which is pretty cool. So looks like, or on your phone. Very nice. So you can get an app as well. I learned something new today. How about that? All right. So let's go on ahead and let's look at another map. I'm going to give it back to Kaya to show us one of my favorite maps. It shows a little bit different data for us. I'll step off to the side. And what do you notice? We definitely have colors, right? Yep. There's not as much movement or anything. Now, this is not a Science on a Sphere data set, but what this does show in blue is like to highlight a lot of where a particular animal lives. Lives in a little bit in Australia, New Zealand, Antarctica, and a little bit of these colder places. Oh, and a little bit in the Galapagos Island, where cold water currents will actually travel all the way up to the Galapagos right there. What animal do you think it might be? Well, one that loves to eat fish. Mostly krill, actually. Just kidding, krill. They sometimes will eat fish, and they will also go on ahead and eat squid too. What animal are we talking about? Penguins. So this is one animal that's very much, relied on a lot of these ocean currents that we've been talking about earlier, right? These temperatures, these cold waters, will actually bring up a lot of good nutrients and a lot of plankton for a lot of fish that they like to eat, but also the plankton is what the krill like to eat too. Krill is actually just one kind of plankton, but it's a bigger kind of plankton that's a little bit higher on that plankton food chain. And so these plankton, are a great source of energy and food for all of our penguin friends. Now, if you happen to notice, a lot of those penguins lived in the southern hemisphere, right? And so they haven't been able to cross that equator because that equator region is too hot, as we were able to see, right? But here's some of those penguins that live a little bit more in that Galapagos region, where they have bright, beautiful blue waters, but are still nice and cool, and they're still able to eat some of that cooler water food. That krill, that fish, and some of that squid too, right? So these cooler currents that are brought up along South America help these animals to be able to stay cool and eat tasty, tasty krill. All right, but if we go on ahead and we think about Southern Hemisphere, right? Okay, that's where penguins are from, and they've been able to shift upwards and move downwards, all areas where the currents are nice and cool to get that delicious krill. Well, what about the northern hemisphere, right? Now, they have a whole different set of other animals. But you know what? Even though they aren't super big krill eaters, though some of them do, many of them focus in on some of those smaller fish that they eat. And so with those smaller fish, that happens to be a really big food source for them. But some of them do eat krill. Any guesses to what animals I'm talking about? Right? Here we have a puffin right here. Isn't it great? This one's a horned puffin because you can see the little horn on top of its eye right there. But you can see all of these, well, you can see, I guess it's the back sides of these fish. My apologies. But with these right here, you can see all of these tiny fish. And what do you think these tiny fish eat? Yep, krill, and also other plankton, right? So this is, once again, a different environment, different but similar, right? We have these animals that also eat krill and different plankton, and they are much smaller, but guess who eats them, right? The cousins to the penguins in the north, all of these puffins and auklets, diving birds, all of these friends have basically survived up in the northern hemisphere, and they like to eat a lot of small fish right here. Now, they also might go on ahead and eat some squid too, as squid are pretty much found all over the world, which is a cool topic on its own. But here's some other evidence that these small fish, right, are able to benefit from all of that water and all the cool water and those currents that are bringing it up along Alaska and the Arctic, all up there, right? So it's pretty cool to be able to see how all of these currents and how the oceans and how the wind itself helps drive all of these animals to be happy and healthy. All right, folks. Well, unfortunately, we are all out of time today, but just want to say thank you for joining us. Let me grab my space helmet one more time. All right, folks. Thank you very much for joining us today. I think my space helmet now has wings. That may help me to fly. Maybe to our next planet, perhaps. Well, we're mainly focused on Earth here, though. But once again, thank you so very much for joining us. If you are interested, again, in learning a little bit more about the different processes that our Earth goes through and seeing some really awesome images, would highly recommend the SOS Explorer app, right? So it's a really cool way to be able to check out our Earth in a whole new lens that we've never seen before. And lastly, if you do have any questions, feel free to go on ahead and email us at live@lbaop.org. Stands for Long Beach Aquarium of Pacific.org. All right, well, that's it for the programs for today, folks. Thanks for joining us. Definitely looking forward to seeing you another time here at the Aquarium of the Pacific. I will take my helmet and head on off for the day. Have a great day, everyone. Bye.